Let's talk about percentiles. First thing I'm going to say is that there is no set standard when doing percentiles. If you search the internet for information on percentiles, you will find many different ways to approach the same problem. In this video, I will be sticking to the method which the author, Mario Triola, has established for us. A percentile is a measure of how much of your total dataset an individual data value is greater than. For example, if you receive your SAT scores and they tell you that you scored in the 90th percentile, it means that you've done better than 90% of the people who took the test. If you scored in the 60th percentile, then you've done better than 60% of the people who took the test. One thing to note is that there is no 100th percentile. It's easy to see why in this example. Being in the 100th percentile means that you've done better than everyone who took the test. But you were one of the persons who took the test. So what you're saying is that you did better than everyone, including yourself.
That's just crazy talk.
In the same sense, this means that there is no 0 percentile, because it would mean that you had done worse than everyone who took the test, including yourself. And this too is
crazy talk.
Let's look at how to find a percentile of some value in a dataset. We are asked to find the percentile of 54. This means that we are trying to find what percentage of the total dataset 54 is greater than. The first thing you want to do is order your set in increasing order. Now let's count how many numbers are less than 54. Numbers are less than 54 out of the total 9. Since your answer is not a whole number, we must round. Remember, if the decimal place is 5 or above, we round up, and if it's 4 or below, we round down. Let's try another example. What is the percentile of 11.8? Since there are 20 numbers less than 11.8, 20 would be in our numerator, and 50, the total number of data values, would be in our denominator. Thus, 11.8 is in the 40th percentile. Let's now try to find the data value given its percentile. If I input the percentile and the total number of data values into my equation, it gives back some locator number. This locator number will help us identify the data value that we are looking for by telling us which data box to refer to. For example, if I have a data set with 11 values, we first rearrange them in ascending order. Then, if we are given that our locator computes to 5, then we are referring to this box and the data value that's inside of it. But this is where it gets a little confusing. When we compute the locator, two things can occur. First is if the locator is a whole number. In this case, the data value we are looking for is the average of the values in the Lth and the L plus 1 box. For example, The other case is if the locator computes to not a whole number. In that case, our answer is the data value in the L plus 1th box. There are 3 special percentiles. These are the 25th, the 50th, and the 75th percentile. These are commonly referred to as quartiles and have special notations of Q1, Q2, and Q3. Here's a quick way to find the quartiles given a small data set. After you order your set, take one value away from each side until you reach the middle. The middle number is the median and also Q2. Notice how my data is now split into 2 groups. If I find the median of the first group, I can find Q1. And if I find the median of the second group, I can find Q3. If I put the quartiles together with my smallest data value and largest data value, I create what we call the 5-number summary. This is the basis for creating a box plot, and it will come in handy for the next video.